This video contains an advert for LEGO Art, and this video is sponsored by LEGO Group. LEGO Group have launched a new range of LEGO art, and they've asked me to make a virtual art gallery experience to display the Marvel Avengers Iron Man set. We've done quite a bit on it already, but before we recap on what we did last time, let's have another quick look at the product. Amazing! And don't forget there's 3 different images you can build, although if you want to build them all at once you'll have to buy 3 sets, but if you do buy 3 sets you can build 1 mega image of Iron Man using them all at once. So you'll have noticed when I was building this that it's made up of 9 tiles, so I'm going to be building a robot with 9 robot arms that can hold each of the tiles and break the image up and put it back together, and that's going to be on this base that we made last time with an illuminated core and omni-directional wheels, and that's going to carry the 9 robot arms. We left wires sticking out the top of this in part 1, and these are PWM wires that go down to the base to drive the motor drivers to actually control the wheels. We've also got 5 volts and grounds coming back up. So before I fit the robot arms and everything on the top here, we're going to put some electronics in and see if we can control those wheels. Our main microcontroller is an Arduino Mega, and that's because it can control up to 54 servos. We need 27, as well as the 3 motors using 6 PWMs. And we're going to be putting this shield on, which is a Dmx shield, so I can control everything with Dmx software. And that's similar to what I did in my Performance Robot series. So here's my test setup. I've got that shield attached, and I've got a little 3D printed chassis mount there, which we'll look at in a minute. And I've also jumpered my serial, so it's using serial 1 on the Arduino Mega instead of serial 0, so I can still use the USB debug. This is a Dmx interface, which is actually lots of RS485 converters in a box attached to a USB hub, and I've got for now a Dmx cable attached from one of these onto my Arduino shield for Dmx, and eventually we're replacing this cable with a wireless solution. And I've written some code on the Arduino using the Dmx serial library, and I've hacked that library to use serial 1. There's actually a switch in the source if you look at that, and basically I've just set up a receiver and set up the serial port so we can debug it. And down here all we're doing is saying if 10 milliseconds has elapsed, then go and read 2 channels and go and print those out to the serial terminal. So I've got my serial plotter here, and I've also got some Dmx software attached to that Dmx interface. And this is Q Light Controller Plus, which is free open source software. So if I go and move these 2 channels, we should see that we've got data on the Arduino coming back through that debug. We don't want a cable trailing round though, so I've got this wireless Dmx interface. So I've got my Arduino, the shield and the Dmx dongle all connected to this curious star looking thing. The dongle actually needs 5 volts, so I've run the wires into the 5 volt terminals of the Arduino. And I've also got this flat plate, and that sits underneath, or more accurately on the other side of that aluminium square section pole. and that is going to hold the robot arms, and this is going to mount the electronics. I've got these red standoffs in between the two plates, and those are the places that the 9 robot arms attach on the front. So I've got my 5 volts and ground that go to the batteries and the regulator in the base of the robot, and for now I've connected one digital pin, and that goes down to the base as well to the other Arduino that controls the lighting. And that turns on and off the lights remotely when I fade up and down a DMX channel. And yes, we could of course fade those in and out instead of just turning them on and off, but that actually turns the lights on and off really quickly to achieve that effect, and that wreaks havoc with the camera and the shutter rate, so for now they just come on or they go off. But that's the least of our problems. We've still got to drive round and we've still got to control 9 robot arms. So let's talk about driving these wheels. We've got 3 Omni wheels and they're all 120 degrees apart from each other to make up our 360 degree circle. And we need to be able to drive forwards and backwards and left and right and also rotate. Now driving forwards and backwards is easy enough because we can just drive these wheels in this direction, and this one will slide because it's got those little Omni wheels all round the outside, so that's very easy. But what about when it comes to driving this way? Well, that's not too hard. We can drive this wheel this way, and we can drive this wheel this way, and we can drive this wheel this way. But these aren't all facing in the same direction, so we need to work out the velocity to drive these wheels to proportionally that it goes in a perfectly straight line, and of course we need to do that in both directions. But that's a really easy problem to solve. So if we think about our 3 wheels here, which are 120 degrees apart, and we just basically extend this line here to make a right angle triangle, what we need to do is work out the relationship between this length of the line and this length of the line. And this is very easy to solve because it's just a right angle triangle, and we can do that with trigonometry. Basically what we need to do is the cosine of this angle, and that will work out the relationship between these two. And that is the cosine of 60 degrees because that's half of 120 degrees, and the cosine of 60 is 0.5. And what you'll find in fact is that this line is exactly half the distance of this line. So all we need to do is run the wheels here at 0.5 the speed of this wheel. Now, one of the challenges with using DMX to control a robot like this is that there's no negative numbers in DMX. All we get is channels that range from 0 to 255, where the default on a lighting desk or in lighting desk software is generally 0. So we could say that 127 is stationary, and then moving up to 255 makes it drive forward, and moving down to 0 makes it drive the other way. But I really don't want to be in a position where 0, the default, is driving full speed in 2 directions and spinning as fast as it goes. So instead I'm going to assign 6 channels for driving, all with 0 as the off position, 1 channel for driving forwards, 1 for driving backwards, 1 for driving left, 1 for driving right, and 1 for twisting in each direction, which just adds something to all the wheels because they all face in a circle anyway. So we've got 6 channels assigned on the desk. The first one, as before, turns the lights on. The next one makes it drive forwards. The next one makes it drive backwards. The next 2 make it drive either way, in a straight line sideways. And the last 2 make it rotate in either direction. And yes, we're going to be mixing those together and doing fades and transitions between them so that we can do all sorts of fancy stuff like drive along while turning and transitioning sideways and all sorts of things like that. But that demo's coming up later in the video. Right now we need to build the 9 robot arms to hold the Lego art tiles. Each one of those has got 3 motors, so that's 27 servos that need assembling and wiring in. So that's the first 9 servos partially assembled. We're going to fit those on the robot to calibrate all the 0 positions, and then we can work on the next 9 and the next 9. There's quite a bit more wiring around the back now. We've got those servos attached to 9 digital pins on the Arduino, and we've got an additional 7.4 volt LiPo which is powering them because they'll run straight off 7.4 volts, so we don't need any extra voltage regulators. But let's see what they do. All of the outer servos are attached to one fader, so I can move them all at once, and that won't be the case with the next 2 stages, which will be independent, but for now this is just the main feature to open and close the display. The middle one's separate, and that's because it's special, so that's on its own channel for now. On top of those 9 motors at the base of each arm, I've now added 1 for the middle, and we've still got 1 to add that's actually going to tip the Lego tile on the end, and that means that we can do all sorts of fancy effects moving them all the way around. I've also covered my servos with black covers, so we can't see that red and white writing anymore, so it doesn't detract from the Lego art set, and we just keep this as bland as we can. So that's all of the 9 arms built with 3 motors on each one, and at the end of each arm we've got this clamp, and each clamp holds 1/9 of the Lego art set. So now I need to break this up, attach all the pieces, and I've got quite a lot of calibration and programming to do. Well, I hope you enjoyed that. Thanks again to LEGO Group for making this project possible, and don't forget to check out LEGO Art. Alright, that's all for now.